Welcome to AP Physics Made Easy. My name is Eric Sampson, and what I want to do is get you a 5 on your AP Physics test. To do that, you're going to have to learn a little bit of physics, and I'm here to help you do that. Today, we're going to look at deriving expressions, something we have to do quite a bit on the AP test. So let's get going. So it's a pretty common task on the AP test to be given like a scenario and then asked to express one variable in terms of other specific variables and constants. So let me give you an example of a problem like that. Okay, and it's kind of daunting the first time you look at these, right? So, okay, here's an example. Car A is traveling to the right at a constant speed v. It passes a police car that's at rest on the side of the road. The police car immediately begins to accelerate at A, catching up with the car after traveling distance d. Write an expression for the acceleration of the police car in terms of v and d. And I can see how you would look at it and go like, man, why did I sign up for this course, right? But you know what? We're going to learn how to unpack this, and it's really not as challenging as it seems. At least it isn't if you learned your kinematic equations like I asked you to do in an earlier episode. Okay, so what's your first step? Your first step is you've got to decide which equations apply here. So when I look at this, one thing I'm going to notice is this. I see that the car A is traveling at a constant speed. And if it's a constant speed, that's something pretty important. Since it's traveling at constant speed, there's only one equation we can use. And if you paid attention to that episode about kinematic equations, you would know that this is the only equation you can use when an object is not accelerating. Okay, so it just says the velocity is equal to the distance traveled divided by the time needed to make that travel happen. All right, so that's the equation we're going to use for the car. All right, now I see the police car was at rest at the side of the road. That's an important thing to pay attention to. It accelerates at A, so this equation's out. It catches up to the car after distance d. Okay, so let's see what I have here. All right, so now I'm going to say, well, I know the police car is accelerating from rest, and I know that it's going to travel a certain distance in a certain amount of time. So therefore, there's an equation that's going to work, and it's this one here. I've told you before that this is pretty much the most useful equation in AP Physics when it comes up so much on the test. So I'm going to use this one here. Instead of delta x, we're just going to say d, because that's what they gave us in the equation. So d is equal to 1/2 at squared, where d is the distance the police car traveled, a is the acceleration of the police car, and t squared is the amount of, t is the amount of time it took to catch up with the car. So the next thing we want to do is we want to eliminate the unwanted variables by expressing them in terms of other variables. So in this case, what we've got is we know that we're told to express the acceleration of the police car in terms of d and v. So really I should end up with just a, d, and v in my expression, and I can't have t. Now before I had t in both equations for the car that's traveling at constant speed and the one that's accelerating. And so I've got to eliminate those. And here's how I'm going to do that is I'm going to express time in terms of these other variables. So first of all, both vehicles traveled for the same amount of time. So that the time it took the police car to catch up with the other car is the same amount of time that the car was traveling. So what I'm going to do is this. I'm going to take the equation for car A, and I'm simply going to re-express it for t. So I'm just going to rearrange it this way. So now that I've got this, I say, okay, now I know that t is equal to distance over velocity. I can now use distance over velocity instead of t in the equation for the police car. And that's going to make things really a lot easier for me. So the third and final step is I just substitute that new expression I came up with into the equation I'm going to be using, and then eliminate any unwanted variables and rearrange it for the variable I was asked to solve for. So let's just look at this example that we have here. How about it? Okay. So we were asked to write an expression for the acceleration of the police car. And so what we need to do is we need to take the equation for the police car and just substitute this d over v for t, like we just worked out in our previous example. So I'm going to start with the equation for the police car. D equals 1/2 at squared. This is the equation we use for an object that is accelerating from rest for a given amount of time and going a certain distance. So now I'm simply going to take t and substitute it with dv, but I got to be careful because this t is squared. So when I do that, I have to be careful to use parentheses here. Otherwise, I might just end up squaring the d instead of the v as well. All right, so I'm just going to take this t, substitute it with this. All right, now I'm going to go ahead and distribute this square across this. I don't want to have these parentheses anymore, so I'm just going to go ahead and square both things. All right, it's a pretty good habit to get into. And now I'm really close to where I need to be now, right? So what I have to do now is I just need to isolate the A because it says write an expression for the acceleration of the police car. All right, so I want to say A equals, right? Not D equals, right? So I'm basically going to multiply both sides by 2 to clear out this. So that gives me 2D. Now what I have to do is I have to multiply by V squared and divide by D squared, which gives me this. And basically, I'm essentially there, except I've got D in both the numerator and the denominator, so that's a little bit sloppy, so I'll go ahead and get rid of that. And I end up with my final expression, which is the acceleration of the police car is equal to 2 times the velocity of the car squared divided by the distance traveled. And who would have guessed, right? I mean, it's really quite beautiful how this works. And this is so simple. And now we could use this to do other things. Like we might be asked, instead of to write the expression, we might be asked to maybe use proportional reasoning. All right, so let's look at how we'd use proportional reasoning with this. So I have my newly arrived at expression. And so let's just say I was asked this. What would the acceleration for the police car have to be to catch up with car A if car A was traveling at 2v instead of v? All right, so I look at my equation here and I see, well, how is A proportional to v? Well, the answer is A is proportional to v squared. And so now I'm going to take v and I'm going to substitute it with 2v. And again, I have to be careful and put it in parentheses, because if I don't do that, I end up screwing up. Okay, so it's basically 2v squared, not 2v squared. Okay, and that, therefore, I'm going to distribute that through the square to both things. So I end up getting with, that gives me 4v squared. And if I want to make it still be equal, then I had to put a 4 in front of the A, because if A is proportional to v squared, then 4v squared is proportional to 4A. Not so hard to do, right? Okay, let's try another one. What if they didn't just give me one variable, they gave me 2 variables I had to work with here? So what if they said, what would the velocity of the car A have to be if the police car was accelerating at 2a and caught up with the car after traveling distance 4d? So basically, I'm trying to say, well, how is v proportional to a and d? So I need to rearrange this a little bit before I write my expression. So I'm basically going to multiply by d. So I'd say d, or AD, is equal to 2v squared, but I just want how it's proportional, how these 3 variables are proportional to each other. So that gives me AD is proportional to v squared. So now I just go ahead and substitute in. I want to isolate the v, because it said what would the velocity of the car be, and it's really important when you're doing proportional reasoning to make sure that whatever variable you've been asked to find is not being raised to any power. It's not being squared or square rooted. It's not in the denominator. It's just the variable by itself. So in order to do that, I had to take the square root of this, and therefore I had to take the square root of this to keep the equality the same. So now I just substitute in the new values for a and d. So when I do that, I had 2a and 4d. Now I'm going to go ahead and multiply through, so that gives me 8ad. And so since I have the square root of 8ad, if this is true here, basically this is being multiplied by the square root of 8. So this needs to be multiplied by the square root of 8, and boom, I'm done. As always, thanks for watching. Remember, if you like this video, go ahead and like this video. Also, consider leaving me a comment. I'd like to hear your feedback, and if there's a video of some of the topic you'd like me to make, I'd be happy to do that. Please be sure to check the description below for a PDF of this, as well as some sample problems with solutions to help you. And of course, do me a solid and hit that old subscribe button for me.